number 96. This is working now with a Venn diagram that involves 3 circles because we have 3 sets. And we have ABC. Okay, and universal set contains 1 through 9. Set A contains 1, 3, 5, 7. Set B contains 1, 3, 4, 6, and 8. Set C contains 1, 4, 5, 6, 7, and 9. Okay, so as before, we want to start with the area of most intersection. So, in putting in our elements, which is what we're instructed to do here. So we want to see, is there any element that's common to all 3 sets? Well, we see a 1. 3's in 2 of them, 5's in 2 of them, 4's in 2 of them, 6's in. Okay, that's the only thing that's common to all 3. So our 1 goes in the region where all 3 intersect, which is right in here. Okay, now next we want to work on just the intersection of 2 sets. So what do sets A and B have in common? Well, of course they have the 1. We know that from before. They both have a 3, and that's it. So A and B, this is the region shared by A and B. We already have the 1, that means the 3 needs to go in the other part of that particular region. Now we need to move on to A intersects C. What do A and C have in common? A and C both have a 1. Okay, I gotta get rid of my highlighting there. They both contain a 1. And let's see, a 5. Whoops, my highlighting's not on. 5 and a 7. A 1, 5, and a 7. So as we look at A intersects C, and let me change my color. A intersects C is that eye-shaped region. What they have in common is 1, 5, and 7. We've got the 1, so we need the 5 and the 7. Alright, so now we're ready to move on to B intersects C. B intersects C. And what do B and C have in common? 1, 4, and 6. So here's the region. Let's see if I can get a different color. Ooh, that's getting messy. Undo that last one. Okay, so it's, let me go to the other pencil. See if I can get a red here. Alright. Here's B intersects C. We already have the 1. So what we want is we need to add the 5 and the 7. Now let's see. B intersects C have 4 and 6. 1, 4, and 6. I got to be on the right one. So these are the 2 we're looking at. Now, so we find where the 3 sets intersect, then we find where the 2 sets, and then we work on the individual sets. So let's look at set A. Do we have everything that's listed in set A? Set A, we need 1, 3, 5, and 7. We've got them all. Okay, and set B, we need 1, 3, 4, 6, and we're missing 8, so we have to put that in there. In set C, so that's taking care of B. Set C, we need 1, 4, 6, and 5, 7, 9. Okay, I've got 5 and 7, but I don't have 9. Okay, now what about the universal set? Well, let's see, we have 1, but we're missing a 2. We don't have a 2 so far. 3, 4, 5, 6, 7, 8, 9. So it looks like that's all of them. So our answer would be that Venn diagram. Okay, and one last one we'll do is, let's do 104. And this is another one where we're shading the regions. A intersect C complement intersect B. And we want to use the 3-set Venn diagram since we have an A, a B, and a C. Instructions are to shade the region for this particular set. A intersect C complement intersect B. So just like I did with the 2 sets, I'm going to number the regions, except this time, because of 3 sets, I actually have 8 regions. So again, I'm going to go through and list the regions in A, C complement, and B. Alright, so A contains 1, 2, 4, and 5. C complement is everything outside of C. Here's C. So 1, 2, 3, and 8. B contains everything inside of B. So that would be 2, 3, 5, and 6. So A intersects C complement. Which regions do they have? They have 1 in common and 2 in common. So that's going to be 1 and 2. And now I want to intersect that with B. A intersects C complement intersect with B. So let's go to a different color. That's going to show up a little better. Those have region 2 in common. So that means that our answer will be region 2. We want to shade region 2, and I'm using the yellow to shade that. Okay, so that's the end of this recording.